Buckle up, everyone, because today we are taking a deep dive into some serious science. We're talking about CERN.
Ooh, CERN.
Yeah,
Yeah.
you know that place where they're smashing atoms? And you sent in
Yeah.
an excerpt from pasted text
Yeah.
about all their new discoveries, and it sounds like some pretty groundbreaking stuff.
It is really exciting stuff.
Yeah. So are you ready to unlock some universe secrets with me today?
Let's unlock them.
Okay, cool. So this excerpt talks a lot about the Large Hadron Collider.
The LHC.
The LHC, yeah. For anyone who maybe hasn't heard of it before, can you give us a quick,
Elevator pitch.
elevator pitch? Yeah, what is this thing?
Okay, so imagine a giant racetrack for particles underground.
Okay.
That's basically the LHC. They use powerful magnets to speed up these tiny particles almost to the speed of light.
Almost at the speed of light?
And then,
That's crazy.
yeah, and then they smash them together and see what happens.
So it's like a demolition derby?
Kind of, but on a subatomic level.
On a subatomic level.
Exactly. It's how we study the fundamental building blocks of the universe.
Oh, okay, so this is how they found, the Higgs boson, right?
Oh, you mean the God particle?
Yeah, the God particle.
Yes, that's right. The LHC played a crucial role in discovering the Higgs boson.
Okay, and remind me again what's so special about this Higgs boson thing.
Right, so the Higgs boson is this particle associated with something called the Higgs field.
Okay.
And this field is what gives other particles their mass.
Wait, so it's like an invisible force field that makes things heavy.
That's a great way to put it.
Whoa.
Yeah, without the Higgs field, everything would be zipping around at the speed of light.
Nothing would weigh anything.
Exactly, we wouldn't exist as we know it.
Oh, wow. Okay, so that's the Higgs boson.
Mm-hmm.
But this excerpt also goes into some pretty mind-blowing stuff about,
Mind-blowing.
dark matter and dark energy.
Ah, yes. The mysteries of the universe.
Right. It says they make up most of the universe, but we barely know anything about them.
Yeah, it's true. Dark matter and dark energy are still huge enigmas.
Enigmas.
We
Okay.
know they're out there. We can see their effects through gravity, but we don't know what they're made of.
So they're like invisible forces shaping the universe.
Pretty much, yeah. It's like trying to solve a puzzle where most of the pieces are missing.
So how does CERN fit into all this?
Well, CERN is at the forefront of trying to unravel these mysteries.
Okay.
They're searching for particles that might interact with dark matter and dark energy, hoping to shed some light on their true nature.
So they're looking for clues to these invisible forces.
Exactly. They're pushing the boundaries of our understanding of the universe.
Now, speaking of pushing boundaries, this excerpt also mentions something about pentaquarks and tetraquarks.
Ah, yes. Those are some exotic particles.
Exotic particles. Okay, and these are new discoveries, right?
Relatively new, yes. They've been creating quite a buzz in the physics world.
Okay, so break it down for me. What are pentaquarks and tetraquarks, and why are they such a big deal?
So you know how everything is made up of atoms?
Yeah.
And atoms have protons and neutrons in their nucleus.
Right.
Well, protons and neutrons are made up of even smaller particles called quarks. And for a long time, we thought quarks only came in groups of 2 or 3. But then CERN discovered particles made of 4 and 5 quarks. Hence the names tetraquarks and pentaquarks.
Whoa, hold on. So we found new, configurations of matter.
Precisely. It's like discovering a new type of Lego block you never knew existed.
So our understanding of how matter is structured was kind of incomplete.
In a way, yes.
Yeah.
These discoveries challenge the Standard Model, which is our current best theory of particle physics.
So the Standard Model is like the rule book for how the universe works, and now we're finding new rules.
That's a great analogy. The Standard Model is incredibly successful, but it can't explain everything.
And these pentaquarks and tetraquarks are like anomalies?
Exactly. They suggest there's more to the story, a deeper level of complexity we're only beginning to glimpse.
This is blowing my mind.
It's pretty amazing, right?
But okay, all this stuff about particles and forces, it's fascinating, but does it have any practical applications? Does it affect our everyday lives?
Oh, absolutely. You see, fundamental research like the kind done at CERN often leads to unexpected technological breakthroughs.
Really?
For example, the World Wide Web was actually invented at CERN.
No way.
Yes, as a way for scientists to share data. And the technologies developed for particle detectors have revolutionized medical imaging.
Wow. So CERN is responsible for the internet and better medical scans.
Among other things. And who knows what future innovations these new discoveries will bring.
Right. So speaking of the future, the excerpt mentions some pretty ambitious plans like this High-Luminosity LHC and the Future Circular Collider.
Ah, yes. Those are exciting projects.
Can you tell us more about those?
Sure. So the High-Luminosity LHC, or HL-LHC, is an upgrade to the existing LHC.
Okay.
It's like giving it a super boost, allowing even more precise measurements of particles like the Higgs boson.
So even more discoveries?
Potentially, yes. And then there's the Future Circular Collider, or FCC, which is a proposed even bigger collider.
Bigger than the LHC.
Much bigger, with a circumference of 100 kilometers.
100 kilometers, that's like a whole city.
It would be a massive undertaking, but it could unlock even more profound secrets of the universe.
Wow. So this quest to understand the universe, it's like it never ends.
It really doesn't. There's always more to discover.
So much to learn.
It's what makes science so exciting.
I agree. So to sum it all up, we've gone deep into CERN's discoveries, from the Higgs boson to these crazy new particles like pentaquarks and tetraquarks.
We've seen how they're challenging the standard model.
Right, and pushing the boundaries of what we know about the universe.
Exactly.
And it all started with human curiosity, this drive to understand the world around us.
That's at the heart of it all.
So if anything we've talked about today sparked your interest, I encourage you to dive deeper.
Keep that curiosity burning.
Because there's a whole universe out there waiting to be explored.
Infinite possibilities.
Until next time.
Deep exploring.